Hey guys, Travis Gillespie here. We've been converting metric units, and that mnemonic we've been using is King Henry died by drinking chocolate milk. Let's go ahead and write those prefixes down real quick. K stands for kilo, K-I-L-O. H stands for hecto, H-E-C-T-O. D stands for deca, D-E-K-A. B stands for your base set of units. D stands for deci, D-E-C-I. C stands for centi, C-E-N-T-I. And M stands for milli, M-I-L-L-I. Now I just want to make a quick note. As you move to the left throughout the metric system, the units are getting larger. As you move to the right throughout the metric system, the units are getting smaller. This G represents grams. Then I have an M for meters and a capital L for liters. These are our base units, and we can build upon these units with the prefixes throughout the metric system. Let's go over to kilo, and if I were measuring in grams, well, I'd have kilograms, so capital K, little g. If you're measuring kilometers, capital K, little m, and kiloliters, capital K, big L, capital L. Let's move over to hecto. I've got to change colors real quick. So now we have HG for hectogram, HM, and HL. Deca, let's move over to deca, but I'm going to change colors real quick. So we have, for deca, I'm going to use D, A, and G, D, A, M, D, A, L, capital L. And let's move over to deci. We have DG, DM, and DL. Capital L. Centi, well, we're going to get CG, CM, CL. And for milli, well, we have MG, MM, and ML. Now, this is a capital L, and I just want to make a note. There might be some cases when you're reading your textbook or you're in a classroom and you come across a lowercase l. Well, regardless, in either case, capital L or lowercase l, both abbreviations, they both represent milliliters. And I'm just going to erase this abbreviation on bottom to keep the table simple. So let's start converting some units. So let's pretend in this first problem you have 1.75 meters and you want to convert it to centimeters. So your first step, you've got to locate this first set of units. In this case, it happens to be meters. Let's locate meters in this table. But be real careful and make sure that you don't locate this little m to represent meters, because this little m represents milli. Remember, meter, it represents the base unit. So I'm going to go down to little m here. And now I have to move to centimeters. Well, I'm going to move 2 units to the right. So I'm asking myself 2 questions here. How many units do I have to move to get to the new location, a new set of units, and in what direction? In this case, I already stated it is 2 units to the right, which tells us how many units you'll move the decimal, and it tells you in what direction you'll move that decimal. We said 2 units to the right, 1, 2. 1.75 meters is equivalent to 175 centimeters. I'm going to box that answer up. And let's look at another problem. Well, let's pretend that this time we have 14 centimeters and we want to convert it to meters. First thing I have to do is locate centimeters in the table. So centimeters is here, and I need to move to meters here. I'm going to ask myself, how many units do I have to move, and in what direction will I move? Well, I'm going to move 2 units to the left. Well, let's take 14 and we're going to rewrite that number below. And I'm going to put a decimal down right next to it where it should go. And then I'm going to move this decimal, the number of units that I had to move from centimeters to meters, and I'm going to move it in that same direction, moving it to the left. So we're moving it 2 units to the left. So now it will end up here before the 1. So 14 centimeters is equivalent to 0.14 meters. Let's box this up and take a look at both examples real quick. Notice in this first problem, we started at meters and moved to centimeters. Meters, it's a larger set of units than centimeters. But the value 1.75 is smaller than centimeter values, which is 175. So let's make a note here. When you're starting with a larger set of units, such as meters, and you're converting to a smaller set of units, well, we've got to take this number and make it bigger, because 1.75 became a larger number. Well, I want you to think, if the number is small, you've got to make it larger. Well, you can do that by moving to the right along this table. But there's a mathematical way of doing it. Just think about multiples of 10. If we're moving 2 spaces to the right, well, we've got to move that decimal 2 spaces to the right. So let's take 1.75 again, 1.75 meters. And when we move a decimal 1 place to the right, well, that's like multiplying by 10. So we've moved 1 place to the right. If we move a second unit over to the right, well, that's like multiplying by 10 again. So 10 times 10 is 100. Well, these are 2 multiples of 10, which is 100, which would move your decimal 2 places to the right. So our decimal would still end here. So the bottom line, you can use the table to help you move along the metric units, or you can use mathematics and multiples of 10. Let's go ahead and look at example 2 real quick. We move from a small set of units, centimeters, to a large set of units, meters. So we moved from centimeters to the left over to meters. But notice the number 14 was larger when you started with centimeters, and it got smaller, 0.14, when you moved or converted to meters. So let's make that note real quick. If you're starting with a small set of units and you're moving to a large set of units, well, your number will be larger, and you're going to have to make it smaller. So think, if your number is larger, make it smaller. Well, we can use the table to help us move that decimal to the left and make a large number small, or we can use multiples of 10. So if we were to move 1 unit to the left, well, that's like dividing by 10 one time. So this first step, it will divide by 10. That moves the decimal 1 space to the left. But we need to get 1 more unit over to the left here. So if I were to divide by 10 one more time, it would move that decimal to the left 1 more time. Well, we have 2 multiples of 10 here. That's just the same as dividing by 100 or dividing by 10 2 times. Let's take a look at another problem real quick, and this time we have an object. It has a mass of 4 kilograms, so capital K, little g, and we want to convert it to grams. So the first thing I have to do is locate kilograms in the table, and it's over here, and I want to convert it to grams. Well, I could use multiples of 10 and solve the problem mathematically, or I can just use the table and say I've got to move 1, 2, 3 units to the right. So I'm going to rewrite 4 below, put a decimal down, and move this decimal 1, 2, 3 units to the right. It will end here. But what do I do with these empty spaces? I'm going to fill them with zeros. So my new number, 4 kilograms, is equivalent to 4,000 grams. So let's write that down and box it up. All right, let's take a look at another problem. This time we have a water bottle that's filled with 0.8 liters, and we want to convert this to milliliters. So let's locate liters in the table. It's right here. And we're going to move that decimal 1, 2, 3 spaces to the right. So rewrite 0.8 below, and move that decimal 1, 2, 3 spaces to the right, and fill in the empty spaces with zeros. So 0.8 liters is equivalent to 800 milliliters. Let's box this up. So regardless of whatever method you choose to convert units in the metric system, if you decide to multiply or divide by multiples of 10, or if you decide to create a table and move between units along that table, you'll still come to the same answer if you're doing the math correctly. See you guys in the next video.